some 3D geometry basics. Let's get past it. Okay. The first problem is about a plane which is ax plus by plus cz plus d equal to 0. That's a plane. And we want to be able to find the reflection of this plane about another plane. This is another plane, a prime x plus b prime y plus c prime z plus d prime equal to 0. This is another plane, and we want to find the reflection of this plane about this plane. That means if this plane is the mirror, this is the object, we want to find the image of this plane about this plane. So this then, let's say, is the plane which is the reflection of this plane about this plane. Now, very clearly, this plane passes through the intersection of these two planes. So it could be looked upon as a linear combination of these two planes, right? That means the equation of this plane could be looked upon as ax plus by plus cz plus d plus lambda times a prime x plus b prime y plus c prime z plus d prime equal to 0. That's the equation of this plane, right? Which is looked upon as a linear combination of these two planes. Now, the only thing left to be sorted out is the value of lambda. If I know lambda, then I know the equation of the required plane. All that you need to then do is look at any point on this plane P, x1, y1, z1, any point on this plane x1, y1, z1, then distance of P from this plane must be equal to distance of P from this plane. Yes or no? Right? Now distance of P from this plane, how do you obtain that? Replace x, y, z by x1, y1, z1. Take the modulus, divide by root a square plus b square plus c squared, right? So mod of distance of x1, y1, z1 from this plane is ax1 plus by1 plus cz1 plus d divided by root a square plus b square plus c square. That's the distance of x1, y1, z1 from this plane. Must be equal to distance of x1, y1, z1 from this plane. Same thing, replace x, y, z in this entire thing by x1, y1, z1. Plus d1 plus lambda into a prime x1 plus b prime y1 plus c prime z1 plus d1 divided by root coefficient of x whole squared, coefficient of y whole squared, coefficient of z whole squared, isn't it? So a plus lambda a prime whole squared plus b plus lambda b prime whole squared plus c plus lambda c prime whole squared. Yes or no? Now, see, this x1, y1, z1 lies on this plane. That means this x1, y1, z1 must satisfy the equation of this plane. That means a prime x1 plus b prime y1 plus c prime z1 plus d prime must be 0. So this will go into oblivion. This will vanish. Right? Yes or no? And ax1 plus by1 plus cz1 plus d1, modulus of that will get cancelled with modulus of ax1 plus by1 plus cz1 plus D. Yes or no? This and this will get cancelled. That means square of the denominator will then be equal to square of the denominator here. Yes or no? Right? Which means a square plus b square plus c squared equal to a square plus b square plus c squared plus lambda squared into a prime squared plus b prime squared plus c prime squared plus twice lambda into a prime plus bb prime plus cc prime. Yes or no? See, square of this, a square plus b square plus c squared, and square of this is a square plus b square plus c squared plus lambda squared into a prime squared plus b prime squared plus c prime squared, and the middle term 2 lambda into a prime plus bb prime plus cc prime. Right? And then this cancels. Now lambda is not 0. Lambda is not 0. So you can divide by lambda, and that gives you lambda equal to minus twice a prime plus bb prime plus cc prime divided by a prime squared plus b prime squared plus c prime squared. That's lambda. Got me? And you can plug in the value of lambda to get the equation of the required plane, which is the mirror image of the original plane. Got me? Let's look at the next problem, problem 2. Can I wipe it off? Problem 2. A point P moves on a plane this is a plane x by a plus y by b plus z by c equal to 1. This is a plane x by a plus y by b plus z by c equal to 1, and P is a point that moves along this plane. O is the origin. O is the origin, and P be any point on this plane. Call it x1, y1, z1. Any point on this plane, call it x1, y1, z1. Now, a plane through P and perpendicular to OP. This is a plane through P and perpendicular to OP. This is the plane passing through P and perpendicular to OP. For different P's, you will get different planes of this kind, right? This plane intersects the coordinate axis in A, B, and C. So let me first find the equation of this plane, right? Do you realize that this is the origin 0, 0, 0? So a normal to this plane, realize that since this plane is perpendicular to OP, OP lies along the normal to the plane, and a vector along this is x1 minus 0 I cap, y1 minus 0 j cap, z1 minus 0 k cap. So a normal to the plane is x1 I cap plus y1 j cap plus z1 k cap is a normal to the plane, right? So instead of ABC, you have x1, y1, z1 for the plane. This plane then must be of the form x1 into x minus x1 plus y1 into y minus y1 plus z1 into z minus z1 equal to 0. Do you realize this is the equation of the plane? Why? See, this is a plane because of it's of the form ax plus by plus cz plus the rest of the terms are d equal to 0, and the coefficient of x is x1, coefficient of y is y1, coefficient of z is z1. So the normal to this plane is x1 I cap plus y1 j cap plus z1 k cap. So this is the required plane, right? This plane could have been written as xx1 plus yy1 plus zz1 equal to d, x1 squared plus y1 squared plus z1 squared. Right? So this plane could have been written as x by, this is like summation x1 squared kind of a thing. So summation x1 squared, which is like x1 squared plus y1 squared plus z1 squared, divided by x1 plus y divided by summation x1 squared y1 plus z divided by summation x1 squared divided by z1, that equal to 1. Right? That's this plane, this variable plane. Why is it variable? Because x1, y1, z1 are variable quantities lying on a fixed plane. Right? Now, so this is the x-intercept of this plane, this is the y-intercept of this plane, and this is the z-intercept of this plane. Yes or no? Right? Now, can I wipe this off? Just remove the clutter from here. So the point A, the x-intercept of this plane is summation x1 squared by x1 0 0. Right? B, the y-intercept of this plane is 0 comma summation x1 squared divided by y1 comma 0, and the point C is 0 0, right, summation x1 squared by z1. These are points A, B, C. Right? Now, there is a plane, for example, drawn through A and parallel to x equal to 0. There is a plane drawn through A and parallel to x equal to 0. Right? What is that plane? This is the x direction, this is the y direction, this is the z direction. Right? This is the point A on the x-axis, right? The point A is on the x-axis. A plane is drawn through A and parallel to x equal to 0. X equal to 0 is the YZ plane, right? This is the plane, huh? Isn't it? So this plane would be x equal to x of A, isn't it? Because all points on this plane have the same as x as that of A. So this plane is x equal to x of A. That means this plane, this required plane would be x equal to this. Yeah, please come. That will be the required plane, x equal to A of this. That will be one plane. Similarly, the second plane would be y equal to this. The third plane would be z equal to this. Yes or no? Right? So the three planes are one plane is x equal to summation x1 squared by x1, y equal to summation x1 squared by y1, and z equal to summation x1 squared by z1. These are the three planes, x equal to that, y equal to that, and z equal to this, right? Yes or no? And these planes intersect at a point Q. See, these x1, y1, z1 are variable numbers. So these planes are variable planes, right? And these planes intersect at x equal to, intersect at a point Q, right? These planes intersect at a point Q. Hey, if there is a plane x equal to 2, y equal to 3, z equal to 4, then what's the point where they intersect? 2, 3, 4, isn't it? If there is a plane x equal to 2, y equal to 3, and z equal to 4, these are three planes, say. Where do they intersect? 2, 3, 4, isn't it? So if there is a plane x equal to this, y equal to this, z equal to this, then the point Q where they intersect would be this, comma this, comma this. That's the point where these planes intersect. Yes or no? So the required point Q is going to be summation x1 squared by x1, comma summation x1 squared by y1, comma summation x1 squared by z1. Yes or no? Now I have to find the locus of Q. That means I want to connect the x, y and z coordinates of Q. I want to connect the x, y and z coordinates of Q in an algebraic manner by eliminating these parameters x1, y1, z1. That's what I want to be able to do, right? And that will be the required locus, right? Now, see, this point lies on this plane. No, this point does not lie on this plane. x1, y1, z1 lies on this plane. So x1, y1, z1 will satisfy this equation? Yes or no? Can I remove all of this? Say the point Q has x coordinate alpha. Alpha is summation x1 squared by alpha by x1, beta equal to summation x1 squared by y1, and gamma is, that's the point Q, summation x1 squared by z1. I want to connect alpha, beta and gamma and generalize that. Replace alpha by x, beta by y and gamma by z. Now x1, y1, z1 lies on this. So x1 by a plus y1 by b plus z1 by c is 1. Yes or no? Where this x1 is like summation x1 squared by alpha. What is y1? Summation x1 squared by beta. What is z1? Summation x1 squared by gamma. Yes or no? So I do the same. I replace x1, y1, z1 in terms of alpha, beta, gamma. So this then turns out to be summation x1 squared into 1 by a alpha plus 1 by b beta plus 1 by c gamma. That's equal to 1. I hope you realize what I've done here. The x1, y1, z1 have been sourced from here. x1 being summation x1 squared by alpha, y1 being summation x1 squared by beta, z1 being summation x1 squared by gamma. That's what I've done here. x1, y1, z1. And then taking summation x1 squared common from the three terms. Right? That's equal to 1. And notice that I bring in alpha here. I bring in x1 there. I bring in beta here. y1 there. I bring in gamma here and z1 there. Right? Now I square and add these. Let me square and add these. So if I square and add these, then the left hand side would be summation x1 squared. Right? x1 squared plus y1 squared plus z1 squared. That's summation x1 squared. And this right hand side would become summation x1 squared whole squared into 1 by alpha squared plus 1 by beta squared plus 1 by gamma squared. Yes or no? Right? When I square and add. So this will get cancelled with this. No? Confused kya? No? And then this summation x1 squared can be replaced by that. That summation x1 squared could be brought into this place. Yes or no? This summation 1 by summation x1 squared is 1 by alpha squared plus 1 by beta squared plus 1 by gamma squared. This summation x1 squared here is 1 by summation x1 squared. And 1 by summation x1 squared is 1 by alpha squared plus 1 by beta squared plus 1 by gamma squared. So this is going to become 1 by alpha squared plus 1 by beta squared plus 1 by gamma squared. That's a relationship connecting alpha, beta and gamma, right? Is that okay? Which means 1 by A alpha plus 1 by B beta plus 1 by C gamma is 1 by alpha squared plus 1 by beta squared plus 1 by gamma squared. Alpha, beta, gamma you can generalize. These are coordinates of the point Q. You can replace them by x, y, z to get the locus of the point Q. That means 1 by ax plus 1 by by plus 1 by cz equal to 1 by x squared plus 1 by y squared plus 1 by z squared. This is what transpires. That's the locus of the point Q. Is that all right? Let's look at problem 3 then. So far so good, right? P is a given point. PM and PN are perpendicular from P to XY and XZ plane. Right? This is problem number 3. I'm assuming you have attempted these problems. Was the sheet given to you earlier? So you would have attempted these problems, right? X, Y, Z. P is a given point. Call it x1, y1, z1. P is some point. Call it x1, y1, z1. It's not located here. I'm only listing it out here. It's located somewhere here, let's say. x1, y1, z1. PM is a perpendicular from P to the xy plane. That means if P is a point here, if P is a certain point here, then PM is this perpendicular. That means M is the foot of the perpendicular from P onto the xy plane. M is the foot of the perpendicular from P onto the xy plane. That's what it means. Now if a point x1, y1, z1 is projected in the xy plane, then its x and y coordinates will remain the same. Its z will become 0. Yes or no? So the projection of the point M, the projection of P is simply going to be x1, y1, 0. That's a projection in the xy plane. Then its projection in the xz plane. Xz plane, matlab y will be 0. That means then its coordinates will become x1, 0, z1. x1, 0, z1. So the point N will be x1, 0, z1. Will be the point N. Right? Okay. Now OP. O to P, the vector is what? x1 I cap plus y1 j cap plus z1 k cap is the vector OP. And bless you. And mod OP is root x1 squared plus y1 squared plus z1 squared. That's mod OP. Right? If OP makes an angle theta with the plane OMN. Look. The plane OMN is like this. This is the plane OMN. This is the plane OMN. I mean, this is not parallel, this is not aligned with the z direction. Let me just, to avoid confusion, let me draw the z direction a little distinctly to prevent this from being, say, this is the z direction. This is the plane. A triangle will always constitute a plane. It's independent plane. a unique plane, right? OP makes an angle theta with the plane OMN. That means if OP is like this, then this angle is theta. See, I hope all of you understand this. If P is the point here, if OP is like this, then this angle is theta. It makes an angle theta with the plane. Now this is the normal to the plane. So it will make an angle 90 minus theta with the normal to the plane. OP makes an angle 90 minus theta with the normal to the plane. Yes or no? 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 So OP makes an angle 90 minus theta with the normal to the plane. Now normal to this plane. I have to find the normal to that plane. 90 minus theta with the normal to the plane determined by OMN. Now how do I find a normal to the plane OMN? OM cross ON will give me a normal to the plane OM cross ON. Yes or no? Now what is OM? OM is the vector x1 I cap plus y1 j cap is OM. Right? What's the vector ON? x1 I cap plus z1 k cap is the vector ON. So let me find OM cross ON. That will give me the normal to the plane, right? So the normal to the plane is n. Normal to this plane is say n, the vector n, and that's going to be the vector OM cross ON. OM is what? I cap, j cap, k cap, x1, y1, 0, x1, 0, z1. That's the vector n, normal to the plane OMN. So this vector n then gets reduced to I cap into y1 z1 minus j cap into x1 z1 plus k cap into minus x1 y1. Yes or no? So what I do is plus place the minus sign here. That's the normal to this plane, right? Now 90 minus theta is the angle between OP and N, right? So OP dot N is going to be the length OP into the magnitude of N. Magnitude of N is root y1 squared z1 squared plus x1 squared z1 squared plus x1 squared y1 squared. That means root summation x1 squared y1 squared. I hope you realize what I've done. This will represent all possible pairs x, y, y, z, zx, right? Yes or no? That's the magnitude of N into cos 90 minus theta, which would be sine theta. Yes or no? Hey, but what's OP dot N? This x1 I cap plus y1 j cap plus z1 k cap dot y1 z1 I cap minus x1 z1 j cap minus x1 y1 k cap. That means OP dot N separately evaluated will give me x1 y1 z1 minus x1 y1 z1 minus x1 y1 z1. So it will be minus x1 y1 z1. Yes or no? See? If I took the dot product of OP with this, then I get minus x1 y1 z1. Do you see that? So this dot product turns out to be minus x1 y1 z1. So now what we need in this problem is cot square theta. So we should be dealing with cosec square theta. So I bring the sign here so that I could get cosec square theta. So then we end up getting cosec square theta is OP squared into summation x1 squared y1 squared right, which is OP squared. OP squared is x1 squared plus y1 squared plus z1 squared. That's OP squared, and this by this is 1 by x1 squared plus 1 by y1 squared plus 1 by z1 squared. On dividing this by this, I get 1 by x1 squared plus 1 by y1 squared plus 1 by z1 squared. Yes or no? Does it sound good? That's cosec square theta. Right? Now, can I remove all the clutter that I have created? Barring this last result, cosec square theta, the expression for cosec square theta. Can I remove everything else from this? Have you copied it? Okay. Now, alpha, beta, gamma are the angles that OP makes with the coordinate planes x, y, y, z, z, x plane. Right? Say for example, the angle that OP makes with the xy plane. That's alpha. Say angle that OP makes with the xy plane is alpha, right? This is OP. This is OP. It makes an angle alpha with the xy plane. That means it makes an angle 90 minus alpha with a perpendicular to the xy plane. That means it makes an OP makes an angle 90 minus alpha with the k direction. Right? OP makes an angle 90 minus alpha with k direction. Yes or no? Perpendicular to the xy plane. Right? So which means OP dot k cap is mod OP into mod k cap, which is 1, into cos 90 minus alpha, which is sin alpha. Hey, but what's OP dot k cap? Z1 is Z1. Yes or no? So this is, say, Z1 by OP is, or rather cosec alpha is what we need. So cosec alpha is, cosec square alpha is OP squared by Z1. Yes or no? Cosec square alpha is OP squared by Z1. OP dot k cap is Z1, isn't it? OP dot k cap is Z1. Z1 squared. Z1 squared. I'm so sorry. Z1 squared. Right? And which is like, so similarly, cosec square beta could be looked upon as OP squared by y1 squared. Cosec squared gamma is OP squared by x1 squared, and so on and so forth. Yes or no? What is this? OP squared by x1 squared, OP squared by y1 squared, OP squared by z1 squared. That's cosec square theta, isn't it? This is OP squared. OP squared by x1 squared plus OP squared by y1 squared plus OP squared by z1 squared, isn't it? Cosec square theta. OP squared by x1 squared OP squared by y1 squared plus OP squared by z1 squared. That's cosec squared theta. But what is OP squared by x1 squared? OP squared by y1 squared, OP squared by z1 squared? That's cosec square alpha plus cosec square beta plus cosec square gamma. And replace these cosec square by 1 plus cot squared. 1 plus cot square theta would be 1 plus cosec cot square alpha, 1 plus cot square beta, 1 plus cot square gamma. So 3 on this side, 1 on this side, so 2 on right hand side. So you will get cot square theta is cot square alpha plus cot square beta plus cot square gamma plus 2 is what you will get. Got it? Easy problem, just that you have to maintain concentration, you have to maintain patience. It's a problem of patience, right? Just feel confident about what you're doing and move on. The result will come on its own. Shall we move then? Problem 4. We have points P, 2, 3, 2, Q, which is 1, 1, 1, R, which is 3, minus 2, 1, S, which is 7, 1, 4. We want to find the volume of the tetrahedron formed out of PQRS. So take any one vector as the base vector. So what's the vector PQ? The vector PQ is minus I cap minus 2j cap minus k cap. That's a vector PQ. Do you realize that? The vector PR is I cap minus 5j cap minus k cap, right? That's a vector PR. The vector PS is what? 5i cap minus 2j cap plus 2k cap. That's a vector PS. And all that you need to do is the volume of the would be 1/6 scalar triple product of these PQ, PR, PS, or its magnitude. If it turns out to be a negative number, we take its magnitude. That means 1/6 of the following determinant: minus 1, minus 2, minus 1, 1, minus 5, minus 1, 5, minus 2, 2. This or its magnitude will turn out to be the volume of the tetrahedron. Have you evaluated this? No? How much? No? No, didn't evaluate. Okay. And it's not like you have to take PQ, PR, PS. You could have taken QP, QR, QS. Or you could have taken SR, SQ, SP. Scalar triple product of any. You will have to choose one of them as the base. Right? I've worked this out for you, right, in the class, the volume of the tetrahedron. Now, there is a plane given in problem 5. There is a plane given. And there is a line joining these 2 points. Say P is a point x1, y1, z1, and Q is a point x2, y2, z2. We want to find the ratio Pm is to Qm. We want to show that Pm is to Qn is minus of ax1 plus by1 plus cz1 by d, etc. Right? We want to find Pm is to Qn. Now, suppose you assume it to be lambda is to 1. Right? Then the coordinates of M would be what from section formula? Lambda x2 plus x1 by lambda plus 1, lambda y2 plus y1 by lambda plus 1, lambda z2 plus z1 by lambda plus 1. These are the coordinates of the point M. Hey, but M lies on this. So M must satisfy this equation. Yes or no? So A into lambda x2 plus x1 by lambda plus 1. I mean, plugging in the coordinates of M in this equation, plus B into lambda y2 plus y1 by lambda plus 1. C into lambda z2 plus z1 by lambda plus 1 plus D equal to 0. And you can solve for lambda very easily from this equation. Right? Multiply throughout by lambda plus 1 and solve for lambda. And that will be the required ratio. Yes or no? So there is a plane that meets a set of three mutually perpendicular planes. Three mutually perpendicular planes you can call as x, y, y, z, z, x. Right? In the sides of a triangle whose angles are A, B, C. So there is this plane, say, the triangle will determine the plane at it, and it intersects the x, y, z axis at points A, B, C. This is the first plane. That means the plane constituted out of ABC is the first plane. Show that the squares of the cosines of the angles which the first plane makes with the other planes are cot B, cot C, cot C, cot A, cot A, cot B. Now, first of all, let's say alpha is the angle that ABC makes with the XY plane. Right? That means alpha is the angle that ABC 90 minus alpha is the angle that ABC makes with a normal to the XY plane. That means with the K direction. So with the K direction, ABC makes this angle. Right? Say equation of this plane, if A is A0, 0, B is 0, 0, B, C is 0, 0, 0, B, 0, and C is 0, 0, C. Right? Then the equation of the plane ABC is x by A plus y by B plus z by C equal to 1. That's the equation of the plane ABC. Right? Now, what's a normal to this plane? What's a normal to this plane? Huh? 1 by A I cap plus 1 by B J cap plus 1 by C K cap. Why? Coefficient of x is not A here, is 1 by A. Coefficient of y is 1 by B. Coefficient of z is 1 by C. That's a normal to this plane. Now, angle between this normal n and k cap is 90 minus alpha. N and k cap is 90 minus alpha. That means n dot k cap is magnitude of n, which is root 1 by A squared plus 1 by B squared plus 1 by C squared. That's magnitude of n into magnitude of k cap, which is 1, and cos 90 minus alpha, which is sin alpha. Yes or no? That's n dot k cap. With the normal to the plane, they say. Okay, let me just read. Square with the first plane makes with the other planes. Oh, okay. N dot k cap. Yeah, normal to the plane. That's alpha. You're right. Show that the square cosine with the first plane makes with the other planes. Yes. Angle between n and right. This must be cos alpha. You're right. Yes. The angle that this plane makes with the xy plane is alpha. So the angle that the normal to this plane making with the normal to the xy plane will also be alpha. Yes, you're right. So this will be into cos alpha. I'll repeat. See, what's given is angle between the plane ABC and the xy plane is alpha. That's given. That means angle between the normal to ABC and the normal to the xy plane will also be alpha. This is the normal to the xy plane. This is the normal to the xy plane. This is the normal to the plane ABC. Angle between these two planes will also be, these two normals will also be alpha. Thanks. So that's, and what is n dot k cap? N is this, dot k cap, that's 1 by c. N dot k cap is 1 by c, yes or no? N dot k cap is 1 by c. So that gives us cos squared alpha as a square b squared by a square b square plus b square c square plus c squared a squared. That's cos squared alpha. B square c squared by a square b square plus b square c squared plus c squared a squared. That's cos squared alpha, right? Now, similarly, cos square beta, cos square gamma, etc. Right? Now, we want to show, for example, that cos square, similar manner, you could write cos square beta, cos square gamma. That will be b square c square by same denominator. Cos square gamma will be c square a square by the same denominator, etc. Right? So I'm not writing it down separately for you. Now, what is cot A cot B? Say, let me find out the value of cot A cot B. Let me find out the value of cot A cot B. Let me find out cot A only. Let me find out cot A only. Why cot A cot B? Let me just find out cot A only. Do you realize that's cos A by sin A? Which means AB dot AC divided by mod of AB cross AC. Yes or no? Do you realize why? AB dot AC is AB into AC into cos A. Mod of AB cross AC is AB into AC into sin A. Yes or no? That will give me cot A, right? Let me evaluate this AB dot AC and AB cross AC. Mod of AB cross AC. What's the vector AB? Minus A I cap plus B J cap. Right? 0 minus A I cap, B minus 0 J cap plus K cap is 0. Right? 0 K cap. Right? That's AB. What is AC? The vector AC? Minus A I cap plus C K cap. Right? What's AB dot AC? Is A squared? Yes or no? Is A squared? That's AB dot AC. Let me evaluate AB cross AC. That's I cap, J cap, K cap minus A, B, 0 minus A, 0, C. That's right? Which is I cap into BC minus J cap into minus AC, so plus AC plus K cap into AB, right? And mod of AB cross AC would be root A square B square plus B square C squared plus C squared A squared. That's mod of AB cross AC, right? So plugging into this, AB dot AC is A squared divided by mod of AB cross AC is root A squared B squared plus B square C square plus C squared A squared. Yes or no? Right? Similarly, cot B is going to be B square in exactly the same way divided by the same denominator. Cot A cot B. Cot A cot B is going to be A square B squared divided by A square B square plus B square C square plus C squared A squared, which is what? Which is cos square alpha, etc. Yes or no? Number 7. A variable plane makes intercepts on the coordinate axis such that the sum of the squares is constant and is equal to k squared. This is a variable plane. This is a variable plane. Now, it makes intercepts on the x, y, z axis such that the sum of the squares of the intercepts is a constant, k squared. We want to find the locus of the foot of the perpendicular from O. We want to find the locus of the foot of the perpendicular from O onto this plane. That's what we want to be able to do, right? That means O is 0, 0. P is say x1, y1, z1. We want to be able to connect x1, y1, z1 and generalize that, right? Now, what's a normal to this plane? x1 I cap plus y1 j cap plus z1 k cap is a normal to this plane, right? Clear? The equation of this plane would be x1 into x minus x1 plus y1 into y minus y1 plus z1 into z minus z1 equal to 0. Yes or no? This plane passes through x1, y1, z1. This is the equation of the variable plane, and x1 I cap plus y1 j cap plus z1 k cap is a normal to the plane. Yes or no? This then would be the equation of the plane. This then would be the equation of the plane. Now, on simplifying, x divided by x1 squared plus y1 squared plus z1 squared will come here. That is summation x1 squared, which is x1 squared plus y1 squared plus z1 squared plus y divided by summation x1 squared divided by y1 plus z divided by summation x1 squared divided by z1 equal to 1. That's the equation of this variable plane, and what's given is that this square plus this square plus this square is k squared. That's given. These are the intercepts of the plane ABC, and sum of the squares of these intercepts is a constant k squared. That's given in the plane. So we have summation x1 squared whole squared into 1 by x1 squared plus 1 by y1 squared plus 1 by z1 squared equal to k squared. This is like x1 squared plus y1 squared plus, so replacing x1, y1, z1 by x, y, z, you get the required locus. That's the required locus, equal to k squared. Right? Next, there is a problem 8. Lx plus my plus nz equal to p is this plane. P is a variable point on this plane. P is a moving point on this plane. It could take any position on this plane. O is a fixed point, the origin. And for every P that lies on this plane, there is a Q that is selected. Let me assume that P and Q are on the same side. Let me assume that P and Q are on the same side. For every P, there is a Q selected, right? In a manner that OP into OQ is P squared. OP into OQ is P squared. Same side of the plane as the origin. Right? Q could have been selected there also. Clear? Now, we want to show that the locus of Q is P into etc. equal to x squared plus y squared plus z squared. We need to figure out the locus of Q, right? Say the coordinates of Q at a certain instant are x1, y1, z1, right? Then I claim that coordinates of P would be lambda x1, lambda y1, lambda z1. Tell me why. Parallel, right? See, after all, OP is some lambda times OQ, isn't it? They are parallel vectors. So OP is like lambda times OQ. OQ is x1 I cap plus y1 j cap plus z1 k cap. So coordinates of P would be lambda x1, lambda y1, lambda z1. Now, what is OP? Distance formula, root x1 squared plus y1 squared plus z1 squared. What is OQ? Root lambda squared x1 squared plus lambda squared y1 squared plus lambda squared z1 squared. So plugging in the same here, lambda squared into x1 squared plus y1 squared plus z1 squared is p squared. You would realize lambda is positive here. Same direction vectors, lambda is positive, so root lambda squared would be lambda, this square. Yes or no? So lambda into x1 squared plus y1 squared plus z1 squared is p squared. Yes or no? Distance formula, this OP is root x1 squared plus y1 squared plus z1 squared. I'm sorry, OQ is root x1 squared plus y1 squared plus z1 squared. OP is replaced. OQ is what? Root lambda squared x1 squared plus lambda squared y1 squared plus lambda squared z1 squared. So I got x1 squared plus y1 squared plus z1 squared common from both. So squared into lambda squared. Root lambda squared is lambda. Lambda is positive because OQ and OP are parallel vectors. So lambda is positive. Right? Yes or no? Now, right. P lies on this line. So coordinates of P must satisfy this equation. So which means coordinates of P are lambda x1, lambda y1, lambda z1. So lambda into replacing x by lambda x1, y by lambda y1. Yes or no? So lambda into L plus Lx1 plus My1 plus Nz1 is P. Yes or no? I hope you realize what I've done. X by lambda x1, y by lambda y1, z by lambda z1 plugged into this. Divide this by this to get the required relationship connecting x1, y1, z1. So you end up getting x1 squared plus y1 squared plus z1 squared divided by Lx1 plus My1 plus Nz1 equal to P. And then generalize this, replace x1, y1, z1 by x, y, z, cross multiply to get the locus of the required point Q. Got me? Show that the equation of the plane containing this line and passing through the point P 0, 7, minus 7. We want to find the equation of the plane containing this line and passing through this point, right? If the plane contains this line passes through minus 1, 3 and minus 2. So the plane will also pass through these points because the plane contains this line. So the equation of the plane would be of the form A into x plus 1 plus B into y minus 3 plus C into z plus 2 equal to 0, where AI plus BJ plus CK is a normal to the plane. Yes or no? Now, since this plane passes through 0, 7, minus 7, I can plug in x equal to 0, y equal to 7 and z equal to minus 7, right? So, A plus 4b minus 5c is 0. That's one equation because the point P lies on this plane. Also, the normal to this plane is AI cap plus BJ cap plus CK cap. Whereas, along the plane is this vector minus 3i cap plus 2j cap plus k cap. And then this dot, this must be 0. So you end up getting minus 3a plus 2b plus c is 0. And then you can apply cross multiplication to find the ratio A is to B is to C, right? So A divided by 4 minus 10, 14, right? See, A divided by 4 plus 10, 14 is minus B divided by 1 minus 15 minus 14, right? Equals C divided by 2 plus 12, 14. So A is to B is to C is 1 is to 1 is to 1. That means I can replace A by 1, B by 1, C by 1. So the required equation is going to be x plus y plus z and then 3 equal to 0. The required plane is going to be x plus y plus z equal to 0. That's going to be the required plane. Right? Now how do you show that a line lies in a plane? Then there is a line given which is like x by 1 is y minus 7 by 2 is z plus 7 by minus 3. So yes, 1 7 minus 7, of course you can check 0 7 minus 7. 0 7 minus 7 is a point on this, which is also a point on this, and I plus j plus k are normal to the plane, dot I plus 2j minus 3k is 0. So then this line will lie in the plane. I have also told you this in my concept class, right? How to check if a line lies in a plane. Have I told you this? Right? The equation of two lines in unsymmetric form is given. One line is of the form y equal to ax plus b, z equal to alpha x plus beta. It's given in the form of two planes. That's the unsymmetric representation of a line. This is line L1 given in the form of two planes. There is another line L2 which is y equal to a prime x plus b prime and z equal to alpha prime x plus beta prime. These are two planes, these are two lines given, right? These two planes in a consolidated manner represent one line, these two planes represent another line. We want to find the condition for the two lines to be coplanar, this line and this line. Condition for two lines to be coplanar is the shortest distance must be 0, that GH must be 0, right? That's a condition for two lines to be coplanar, right? Now, you don't have to do any hanky-panky to convert it into a symmetric form. See, the conversion of these two lines in a symmetric form is as simple as this. Sometimes, just a little bit of an inspection, a little observation will do the trick for you. Right? You don't have to, deploy complicated techniques that were taught in the concept class to convert it into symmetric form. Just look at this. See, in this case, x minus 0 by 1 is actually y minus b by a. Can you see this? Y minus b by a is x minus 0 by 1. Okay. And that's also the same as z minus beta by alpha. That's this line. Converted to symmetric form. Right? That's a symmetric, isn't it? You realize what I've done here? Right? Same thing here. X minus 0 by b prime. See? Is y minus by 1 is y minus b prime by a prime is z minus beta prime by alpha prime. Is this another line? I hope you realize what I've done here. So the two lines have got converted into symmetric form. This is x1 y1 z1, this is x2 y2 z2. This is like a1 b1 c1, this is like a2 b2 c2. Yes or no? What's the expression for the GH, the numerator of GH? x2 minus x1, y2 minus y1, z2 minus z1, and then a1 b1 c1 and a2 b2 c2, that determinant must be 0. So for these lines to be coplanar, the following determinant must be 0. 0, b minus b prime, beta minus beta prime, right? X minus, isn't it? Divided by 1 a alpha, 1 a prime alpha prime. This must be 0. This will be the condition for the two lines to be coplanar. Right?